As numerous enterprises rely on virtual servers, the utilization of VM monitoring tools have become indispensable. Effective VM monitoring is crucial for maintaining optimal performance, identifying issues, and ensuring the effective operations of IT infrastructure. With out-of-the-box reports, graphical. We will start with VM discovery, which is a crucial aspect of managing and monitoring virtualized environment. VM discovery involves identifying, cataloging, and mapping virtual machines across an IT infrastructure. UnityOne discovery relies on protocols like SNMP, WMI, or APIs for data collection as provided by virtualization platforms. In this video, we are going to discover the VMs via private cloud integration. For this purpose, I navigate to the Unity Setup option and click on Onboarding. There is an Add Collector button. I select it and enter the details of the collector. This collector will communicate with the devices hosted in the client environment. Then we move on to the private cloud module under Unity Cloud section to add the private cloud. We will fill all the necessary details such as cloud type, cloud name, data center, credentials, and collector details to discover the VMs. Upon integration, we can see all the device count and private cloud details under summary page. The process of provisioning virtual machines encompasses the creation, deployment, and configuration of these virtual instances within the computing environment. Navigate to Unity Cloud and choose Private Cloud from the drop-down menu to access the management page. Click on the three dots in the top right corner to seamlessly integrate the private cloud into UnityOne. Now, let's go through the essential data required to add a private cloud to UnityOne. Begin by selecting your cloud type and then enter the details for cloud name, data center, host name, username, password, and resource pool name. And after specifying the resource pool name, proceed to choose the collector. To complete the process, click on Submit to automatically include a private cloud in the platform. Having configured your private cloud, UnityOne will provide you with the necessary details for monitoring and managing your assets. You can access the newly created private cloud accounts by navigating the tabs located at the top of the private cloud page. In the present screen, you can observe the summary section. It displays information about the cloud's name, virtualization platform, the number of installed hypervisors, and provisioned virtual machines. Once you register your private cloud into UnityOne, your VMs running on the respective private cloud will be automatically fetched into the platform. Here, we offer customers a centralized VM management dashboard where admins can view and manage all VMs from a single window. To add a new VM, select Add VM. Upon clicking this option, you will be prompted to choose Create a new VM. Proceed by clicking the Next button. Then, you'll see an option to input the desired name for the VM and choose its location. Once more, click on Next. Following that, choose the destination compute resource for the selected location. Here you must select the resource pool credentials. Click on Next to save your preferences and proceed to the next section. In this section, you can choose the storage for configuration and hard disk files. The available storage options are listed under the selected resource pool. And for this instance, we will opt for high capacity storage. Once you proceed, you'll see an option for selecting the guest OS for installation on the virtual machine. Choose both the OS and its version. Available options include Windows, Linux, and other. You can select the OS version based on your preference. Now, it's time to configure the VM hardware. Input the desired number of CPUs, memory allocation, new hard disk specifications, and the necessary new network details. The selection of these parameters should align with the preferences of the network technician. The final page is the summary page, displaying all the previously provided details. Here you can thoroughly review and confirm all the information before clicking on Submit. Shortly after, the virtual machine will be created. To manage your VMs, go to the private cloud window which comes under UnityOne section. Users needs to choose Virtual Machines tab. Users has the options to create VM via deploy OVA or deploy OVF and add VM options. Users will also be able to see the current deployed VMs with their names, statuses, types, operating systems, management IPs, and action buttons for VM management. They can power on and off a VM, open the VMs in the same or different windows, make configuration changes, see statistics, and perform more actions. Users can edit settings, rename, take snapshots, clone VM, reboot VM, mount VMware tool, and delete VM. Next, we'll see how to monitor VMs. For VM monitoring setup, we have two options available: Agent and SNMP. For Agent, we have Agent download option, and for SNMP method, we must provide IP address and SNMP string. In this video, we are using the SNMP as monitoring method. After filling up the details, we click on Activate Monitoring button to enable device monitoring. After activation, multiple tabs will be enabled such as Graphs, Create Graphs, Alerts, and Triggers. Details page shows the device information. In the Graphs page, users can see all the predefined and discovered graphs. In the Create Graph page, users have an option to create different types of graphs like normal, stacked, pie, and exploded for various performance and network hardware metrics such as CPU consumption, memory utilization, disk I/O, disk utilization, interface utilization, and others. Here we are using disk write rate as a metric for our graph. After creation, this graph can be viewed in the Graphs tab. The Alerts tab shows the active problems related to the device. In the Triggers tab, there are predefined triggers available for various metrics. Users can generate their own custom triggers by filling up the required details such as name, severity, rule switch shows all the default and discovered metrics, and the conditions like last check, maximum, minimum, and others for threshold definition. In this video, we are using available memory with average condition of 10 minutes and threshold 90% as a rule to create our trigger. Once the trigger is created successfully, users will get notified and they can search for it in the same page. In UnityOne, we can enable self-healing of the alerts. Here, we are using SNMP service as an example to showcase self-healing and auto-ticketing process. We must create a trigger with required rules and enable self-healing conditions as demonstrated. Currently, we can see there is no problem status for this trigger that we created. We log into the server console and check the status of the SNMP service. We can see the service is active. We will stop the service now so that it will fulfill our trigger condition and generate a problem status. Once the alert is generated, UnityOne executes the script on the machine and enables the service back. We are validating the status of SNMP service in the machine and it is active now. This process also includes auto-ticketing. We can see the event generated, correlated alerts, and conditions for ticket creation. Ticket contains all the details related to the alert. UnityOne is also capable of resolving it upon alert resolution. It also resolves the problem statement from the device. UnityOne also supports integration with collaboration tools like Microsoft Teams and ticketing systems such as ServiceNow, CRM, Jira, and others. Users can view, track, or create tickets from accounts based on the requirements and tenants. In UnityOne, we have auto ticketing feature which benefits the users via generating tickets for various problems related to different devices and can automatically resolve them if the problem no longer exists. UnityOne allows users to send notification to specific recipients. Users can categorize alerts based on severity levels, example critical, warning, and informational. To prioritize responses and common methods include email and SMS notifications. Here, we are demonstrating email notification as a test subject. Users will be able to see an email notification like this on their emails once the notifications are configured. Finally, we have VM mapping and topology. Users can visualize and map dependencies between VMs and other infrastructure components like storage, network, etc. to understand the impact of changes or failures on interconnected systems. Manage multi-cloud IT infrastructure. Users will be able to manage their multi-cloud IT infrastructure. Provisioning and DevOps automation. Users will be able to provision and automate DevOps. Rapid deployment and onboarding. Users will be able to rapidly deploy and onboard their virtual machines. Monitoring and reporting. Users will be able to monitor their VMs and get reports based on different metrics. Cost management. Users will be able to manage cost of virtual machines and get consolidated billing dashboards for tracking, allocating, spending, and optimizing cloud costs. Sustainability. Users will be able to monitor, measure, and manage CO2 emissions across all their VMs with sustainability module. APIs and integration framework. Users will be able to integrate with collaboration tools and ticketing systems. UnityOne offers agentless monitoring of your complete virtualization infrastructure effortlessly, regardless of whether your VMs reside in public or private clouds or within your own data center. UnityOne is a comprehensive SaaS platform bringing together AIOps, DCIM, CMP, sustainability, and cost management module in a single pane of glass for your business needs. Reach out to our sales team for more information. Thank you for watching the video.